Let's make it a new video. Sorry, we got that picture there. It's okay. My kids, White Sox, blah, blah, blah. All right. So I already filled this out. Oh, do get a highlighter out. And actually just two colors. Wherever I have blue and yellow, it's the same. So number one, and this is why I put this as 2 pages in one and your notes already complete, because I don't want you to fumble through all this writing. It's not massively important. It's just setting up an idea. Okay, and the idea is this. I'm going to move this so the computer is like in front of me so they can hear my voice. Number one, I don't know if we've had this yet, but this notation right here, that just means inverse. Okay? And I want you to understand something, and then I'm going to flow to the page 3 of our notes, which for you is page 2 if you flip it over. We have different looking questions today. They look completely different than any others. They look like the second one that I have written here in red that I accidentally left on your notes here. But when I say inverse, what do you say? Switch x and y. So that's exactly what happens here. We know the relationship. I sine an angle measure, and what I get is a ratio. So I sine pi over 6. I know you think that's a ratio, but that's an angle. And you get 1/2. How many times have we mentioned that in class? All right, but then how it'll look is inverse sine of a half equals pi over 6. That's what inverse is. And I want you to understand how these questions look different. You have never seen a question worded like this before, right? When they're worded like this, you got to stop and think about everything that I'm covering right now, but not really. Just understand there's an issue, and it's a weird one. All right, now let's talk about the weird issues. Here's and then sorry, one more thing. We have done this before, so grab your different highlighter and highlight those parts of the sentences. Recall. We've actually had this, and I'm going to write this on here for video purposes. If I could find my pen, I got it right here. Only one-to-one functions have inverses. Guys, we actually had parabolas. A parabola is not one-to-one because it fails the horizontal line test. Remember this? Because if I found the inverse of this, it'd be a parabola that fails the vertical line test. So what we did was restrict the domain so I didn't see this parts. So this part wouldn't be inverted. And then therefore that would pass the vertical. We've done this before. So we've done a thing called restricting the domain. And if you don't remember it, then we'll just have to move on with you. So grab your highlighter again and highlight that portion of the sine graph. Now, do understand that is the sine graph. I got bowl, 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 bowl. Oh, I got my thing in the way here. I was going to get rid of that right away. But where do I get all of my unique values come into play? And it's that yellow part. This yellow part covers all of the range values. Then after that, the range is repeated. Or when you look at the yellow part does pass the horizontal line test, but all the other parts don't. Do you agree with that? Okay, so then that is why when you have a standalone inverse question, this is what the restricted range will be. Your answers can only be from negative pi over 2 to pi over 2. This is why I didn't want to have you graph this. And by the way, the graph, just listen. When I say inverse, what do you say? Darn it, I didn't want to erase that. I had the wrong thing, but that's okay. So what's the flip of 0, 0? 0, 0. What's the flip of pi over 2 comma 1? 1 comma pi over 2. What's the flip of negative pi over 2 comma negative 1? Negative 1 comma negative pi over 2. And I don't think I have my curve quite right. I think it goes kind of like this, but it doesn't really matter. Don't worry about the curvature and how curved it is. If you're going to go to calculus, I think they do make you think about the inverse graphs. I at least covered it with you once. Then you'll have to get refreshers if you go to calculus. Then look at cosine. Cosine has a different restriction because of where 1 to negative 1 happens first. And it happens here, from here to here. So the restricted domain is different for cosine. It's different. All right, and again, one more time, switch x and y. So 0, 1 is now 1, 0. Oddly, maybe I'll change the color so you could see me like doing the graph here. And then switching pi over 2 comma 0 is 0 comma pi over 2. Maybe green would stick out a little bit more. And then pi comma -1 is -1 pi. This is not stuff you'll have to do. You will not have to graph the inverse function. What I'm trying to establish, though, is this. When I have an inverse standalone question, this is a must where my answers come from. And that's why I did that quiz is. I purposely organized the last 6 questions to follow these rules, but I worded it a little differently. And then I bragged to myself about how much I like the quiz is, right? Right. Okay, didn't I leave this highlight, right? Don't you have that junk right there? So I accidentally did not erase this. I got to remember next year that I gave you completed notes for this part to not waste time. All right, and then real quick and by the way, you can see that, right? That's every range value covered just by that graph. Oh, sorry, one more thing. Throw in these asymptotes for yourself. Just those two. Because when you invert a vertical line, you get a horizontal line. I was going to try to say horizontal first. And then drawing this picture, 0, 0 becomes, let's get green, 0, 0. And then all I did for this is very close to pi over 2, comma, large x, very close to pi over 2. So there, that's that point. And then very close to negative pi over 2, very negative, comma, very close to negative pi over 2, then just connect those 3 dots. And it's a curve going that way confined by 2 horizontal asymptotes. I did not write the range, though. This is why these are parentheses, because you cannot have an asymptote as an answer. It's undefined there. So that's got to be parentheses, not brackets. Finish my thought there. Okay, we'll synthesize. You can read all that. And this is the synthesis too. Don't I already have this too written? So sine has these rules for inverse questions. Cosecant's its brother or sister. Same rules. Got it? Cosine and secant, same rules. Here's the kicker. Cotan, I don't even want to go over it. We're just going to do sine, cosine, and tangent. But cotangent doesn't share the same rules as tangent. It's very annoying. It's because of the cotangent graph. I don't even want to get into it. I want you to focus on tan, sine, and cosine only, and then we'll synthesize on this page. Okay, so what do you want to put on this page? We'll start with these angle measures, and if you don't know them, you do. You just did well on the quizzes. Some people in my period 4 and 3. Jack, I hope you're watching this movie. All right. They said I had to mention you. All right. He's targeting me. Sorry, Jack. All right. So, yeah, you know those, right? But then when you go to quadrant 4, this is the inverse section. So whenever I have inverse trig questions, inverse trig standalone questions, I must deal with the restrictions. And these are it. This is the easiest I've ever made this section. That's why I'm redoing the video, because I want to synthesize all the years of me teaching this. Because then when you go to this quadrant, these angle measures have to be expressed as negatives. They cannot be 11 pi over 6, 7 pi over 4. Why? The why is just this. I'm just going to go back. Here's why. Everything I just covered about the graphing. That's why. That's the why. Somebody made this up, and we have to follow the rules, just like PEMDAS. It's like a math rule. And then this is negative pi over 2. All right, but then in quadrant 2, we're allowed to answer those the way we should. 2 pi over 3, 3 pi over 4. So these are the allowed answers for standalone questions that look like this. Those are different looking than what I had on my quizzes. And we should know what I mean by that. On the quizzes, we just had sine of theta equals root 2 over 2. What are the answers from 0 to 2 pi? And you had to answer 2 questions or 2 answers. Okay, and then here's one more thing. When I inverse trig, I'm going to write this like this. All I'm saying is if this is inverse sine, inverse cosine, inverse tangent of a positive ratio, your answer always comes from quadrant 1. Always. So that's easy. You will have, and those are the selected answers. 0 to pi over 2. That's what I have to answer. But then when you inverse trig a negative, for inverse sine of a negative, you're in quadrant 4. And these are the answers that you have to use. That's from our restrictions from the graphing. Same thing with tan. When you inverse tan a negative ratio, you have to answer with a negative angle measure from quadrant 4. These are the rules. But then for cosine, it's in quadrant 2. Notice who never wins. You will never answer a quadrant 3 angle when you're doing an inverse trig standalone question. Got it? And this is it. So it's an added memorization thing. And that's why I don't really like this section too much. I'm just going to be honest. I don't care. I'll throw it out on the YouTube. Go ahead and, cancel me. I've already been trying to people try to cancel me every day, so guess what? I'm still here. Anyway, okay. So inverse cosine of root 3 over 2. What kind of angle is that? Is that an over 6 or an over 3? It's an over 6 because sine of a 30 is 1/2. This is root 3 over 2, so it's an over. What's the answer? It's just pi over 6. You always answer a quadrant 1 angle measure on a standalone. That's why your homework's going to be so fast. Those that know the unit circle, you'll finish your homework in less than 5 minutes. I'm serious. Okay, what kind of reference angle for root 2 over 2 for sine? It's an over what? 4. But how do I have to answer this because of this silly little thing that we got going on? Negative pi over 4 and we move on. That's the rules. Look up here. I can almost have this up here if we can see my notes. I'm accessing this is what you should look at when you're doing your homework. That big circle right there. All right. Okay. Negative 1 over 1. I did say in the quizzes you do want to do that, but really it's just 1. Look at my hand. Okay. So what's the reference angle? It's an over 4. What's the answer? Negative pi over 4. Okay, and it is an over 4. There's a bunch of reasons for it. Y is 1, X is 1. R has to be root 2 through the Pythagorean theorem. It's a 45, 45, 90. I don't know how else to tell you the unit circle. We're beyond you right now. You got to know these ratios. All right, what's the reference angle for sine equaling 1/2? It's pi over 6. We've said that a million times. What's cosine's root 2 over 2? What's the over? It's an over 4. And then it's not negative pi over 4 because cosine's positive in quadrant 4. So what's the answer? 3 pi over 4. Okay, no big deal. Don't feel bad, but that's definitely not true. And then the last one, arctan of root 3 over 3. Which one is that, an over 6 or an over 3? It's an over 6 because I got my hand up in the air. And what I have for my hand is this. I don't know if I could draw a hand. There's a finger, there's a finger, there's a finger. And then this one was down. And then he got his finger cut off. No, I folded this one down. So that's pi over 3. All right. And then that's because it's root 1 over root 3. That's root 3 over 3. This is the hand trick. I'm trying to put this in the video so some people can finally understand the hand trick, even though I showed the video and I've done my hand a million times in this class. So what's the answer? Sorry. What's the answer? Negative pi over 6. Really liking the hand this year. This is, if anyone from 10 years ago watches my videos, and I'm sure they do. Anyway, they'd be like, wow, he always hated the hand trick. All right, now go to your calculator. Okay, I already have these typed in. Oh, that's not the calculator. There we go. I already have these typed in, but I just want to make sure you understand that you are in this mode. When you're going to the calculator, you're in radians. When you're doing this, radians. Okay, and then really I'm just going to show you what I already typed in. But, oh, sorry. You know what I didn't do with you guys? Up here, I did, and I didn't reference it, though. This is just the decimal approximation of pi over 2. So I know I'm going a little bit longer, but you're still, gosh, your homework's going to be so quick. This is negative 1.57 as a decimal. And then I want you to remember that video where they first defined radians and they took this radius and peeled it off and then lopped it on here. Do you remember that video? And then they said this was 1 radian. Remember that video? Can you just say yes? And then they put another length of a radius and then they said that was 2 radians. because that's another radian measure right there. 1 plus 1 is 2. Do you remember that? Because now you should make sense out of your calculator. All right? I'm actually going even more in depth on this. This is a great video. You're so arrogant. All right, anyway. Where did all my stuff go on the bottom? Do you notice that this is all gone? What happened? Where's my mouse? This is fun. The old guy struggling with technology. Okay? Trying to move this. Oh my goodness. This is embarrassing. Okay, and then this back up. There we go. I just had all that stuff gone. So I want that calculator back. Boom. Look at these answers now. So I want you to understand when I inverse cosine 0.4, I got 0.4111. That answer should make sense because 0.411 radians is like right here because this is 1.57 radians pi over 2. It's in quadrant 1. The next one, inverse cosine of pi 1/8. This is an angle measure, and it's 1.44. 1.44 is like right here. It's still in quadrant 1. When I inverse tangent on my calculator, negative root 5 over 2, I get negative 0.84. If this is negative 1.57, then negative 0.85, whatever, is in quadrant 4. The calculator's following the rules as well. It gave me for a negative ratio, a negative angle measure. Right? So I just wanted you to have some thoughts about that. Okay, I'm done. So over explained a lot, but I really hope that helps and makes this section really easy.